We're just doing this getting ready. It's a pretty neat little exercise. Fold a piece of paper in half, crease it. When you unfold it, the paper is divided into 2 rectangles. Agreed? All right. Now, refold the paper, then fold it in half again. Refold it, crease it, fold it in half again, and crease it. So you've folded it twice. Open it up. How many rectangles do you have? So we folded it once, and we produced 2. We folded it twice, we produced 4. Now, fold it 3 times and make a prediction about how many rectangles there's going to be. Fold it 3 times and then unfold it and count them. And there are 8. The question is, how many rectangles will you get if you folded a piece of paper in half 8 times? This is where you're going to start using patterns. So let's look at the pattern of how many rectangles you had after each fold. So, number of rectangles after one fold was
2.
Good. Come on, baby. No. All right. Number of rectangles after one fold was 2, right?
Yeah.
Number of rectangles after 2 folds.
4.
Number of rectangles after 3 folds.
8.
Do you see the pattern?
16.
What's happening each time you make another fold? You're doubling the number of rectangles, aren't you? Okay. So what's the after 4 folds? How many rectangles are you going to have? So that's after 4. So you need 5, 6, 7. They're looking for 8. So right here we're going to have a, and then a, and then a. 256. Okay, 256. So there's your pattern. All right, there's your pattern. There would be, after 8 folds, there would be 256 rectangles on your paper. After 7, you should have 128. All right, today is a lot about definitions. Here's the first definition you got to write down, and we're behind schedule, so we got to go a little quick. Inductive reasoning is reasoning based on patterns you observe. Reasoning based on patterns you observed. Inductive reasoning. Reasoning based on patterns you observe. Write it down. Excuse me? You could title this Reasoning and Conditional Statements. Your next definition, a conjecture. Is a conclusion you reach using inductive reasoning. On page 92, a counterexample. A counterexample is an example that shows that a conjecture is incorrect. Let's also say that it explains why a statement is false. Explains why a statement is false. So if we're finding a counterexample, which is an explanation of why a statement is false, the question is, what is a counterexample for each conjecture? Well, for problem 5a here, we're looking for a counterexample. The statement is, if the name of a month starts with the letter J, it is a summer month. True or false, first of all?
False.
False. Now, give me a statement why it's false. Thank you. January starts with a J and is not in the summer. All right? When you are writing a counterexample, it's got to explain why a statement is false in detail. Okay? You just can't say January starts with a J. January starts with a J and it's not a summer month. Page 97. Yes. That's all. '97. Here's where we're getting into the conditional statements. This is all really important. Key concept box. A conditional is an if-then statement. Hypothesis follows the if. Conclusion follows the then. You want to get those three definitions written down. Conditional is an if-then statement. Hypothesis follows the if. Conclusion follows the then. This symbol right here. You read that as if P, then Q. This symbol is read if P, then Q. And in your Venn diagram over here, here's your hypothesis. And this area represents your conclusion. Read this right here. A conditional expresses the relationship of one thing or set of things to another. The Venn diagram illustrates how the set of things that satisfy the hypothesis lies inside the set of things that satisfy the conclusion. So if we were going to work backwards, and Move this up a little bit. In this Venn diagram, what's the hypothesis? Green. What's the conclusion? Okay. How could you write that as a conditional? Because a conditional is an if-then statement. Could you say, if something? You're allowed to add some words to make the statement make sense. If something is green, then it has color. Has a color. Okay? Something is green, then it has color. So that's working from the Venn diagram backwards to a conditional statement. So a conditional statement is a statement with the words if and then in it. The hypothesis is whatever is following the if. The conclusion is what follows the then. Okay? And that's pretty much what we're doing today. Okay? I want you to look at page 99. Alright, for problems 3 through 5, it says to identify the hypothesis and conclusion. In number 3 here, what's the hypothesis? A figure is a rectangle. What's the conclusion? It has 4 sides. That's all you're doing there, 3, 4, and 5. You're identifying what's after the if and what's after the then. Then, in 6 through 10, you're going to write it as a conditional. So what does a conditional have in it? If and then. You can add other words to make the statement read better or sound better when you read it. So writing Hank Aaron broke Babe Ruth's home run record. Okay? In an if-then statement, you could say something like, if the player's name is Hank Aaron, then he broke Babe Ruth's home run record. Good. Okay? If 3x minus 7 equals 14, then 3x is equal to 21. Okay? So that's how you write each sentence as a conditional. You write it as an if-then statement. On the next page, 11, 12, and 13. We just did an example of that, right? What's blue, the hypothesis or conclusion? Hypothesis. And colors is the? Good. If it's blue, then it has? Okay. Now, in 14 through 17, you're going to read the statement. You're going to determine if it's true or false. If it's true, just write true. If it's false, then you got to write a counterexample. And remember what a counterexample was? Yeah, it's a statement showing that this is false. Okay? And it's got to be a statement. Alright? So if it's true, you can write true and you're done. If it's false, you write false and you got to list a counterexample. Any questions? Page, come on. Page, that was 99, and you're doing 3 through 17. And make sure you check headline.